Okay, here's part 2 of using division with radicals. I just finished 17, and now I'm going to look at number 20. Number 20 again has a radical in the denominator, and not only that, we have a binomial, 2 plus 2 rad 3. It's not going to work to just multiply by rad 3, because what will end up happening is we'll have 2 rad 3 for the first term, and we won't end up getting rid of the radical. This requires the special case, like we just did in 17, of multiplying by the conjugate of this expression, 2 minus 2 rad 3. What's done to the denominator must be done to the numerator. To keep an equivalent fraction, we're trying to simplify this and rationalize this, and we want to have an equivalent fraction. Remember, when multiplying by the conjugate, the middle term drops out, so we'll just multiply 2 times 2, which is 4, and we're going to subtract from that 2 rad 3 times 2 rad 3. 2 rad 3 times 2 rad 3. Well, the outside of this expression will be 4 for the radical, and on the inside, rad 3 times rad 3 is just 3. So we have 2 times 2 is 4, and then 2 rad 3 times 2 rad 3 is 12. In the numerator, 3 times 2 is 6, and 3 times negative 2 rad 3 is negative 6 rad 3. And now we can see that the radical is gone, but we do need to simplify. This becomes negative 8, and the numerator is 6 minus 6 rad 3. Now, we do have a common factor between this number, this coefficient, and this denominator of 2. So I'm going to divide everything by 2. And I get 3 minus 3 rad 3 over negative 4. And I'm going to call that done. Number 21, I'll set it up for us. We're going to multiply, because we have a minus down in here, we have an operation being done, we're going to multiply by the conjugate of square root of 3 plus 3, and in the numerator we'll multiply the same thing. And very carefully we'll multiply out these radicals. Square root of 3 times square root of 3 is 3, and minus 3 times a positive 3 is minus 9. In the numerator, the square root of 3 times the square root of 3 is 3, and the square root of 3 times 3 is plus 3 rad 3. Simplifying further gives 3 plus 3 rad 3 over negative 6. And I see a common factor between this term, this coefficient, and this denominator. Remember, it has to be a common factor for all the terms when you're adding in the numerator. And I'm going to divide everything by 3. So that's 1 plus the square root of 3 all over negative 2. And I'm going to call that done. Okay, on the other side is review. Multiplying out these radicals. Number 24 says square root of 20 times square root of 20. Well, that's equal to 20. Remember, squaring the radical sign makes it go away when you have the inside the same number. I could do this a long way. This is the square root of 400, and that is equal to 20. Number 26, square root of 3 times the square root of 15 is equal to the square root of 45. Remember, when multiplying radicals, you multiply what's on the inside, and then we will need to simplify this. This is 9 times 5. This is 3 times 3. See the perfect square? That needs to come out. We take the square root of 9, which is 3, one of the pair, times what's left, rad 5. And that's the answer for number 26. Remember, with 27, in this example, we're multiplying, so we multiply what's on the outside, that's 12. And then on the inside of the radical is also, well, it's 2 times 3 is 6. So we have 12 times rad 6, and this cannot be simplified any further, so it's done. Number 29, 3 rad 2 times rad 6. Well, 3 times, this is understood to be a 1 out here, is just 3. And inside the radical is 2 times 6, 12. But it's not quite done because 12, the square root of 12, can be simplified to 4 times 3. There's a perfect square right there. So we can take out a 2. So the square root of 12 is 2 rad 3. So I have 3 times, the simplified version of rad 12 is 2 rad 3. So 3 times 2 is 6, and what's left is rad 3. Number 31 through 34 is using the distributive property. Actually, for 33 and 34, you'll notice that these are conjugates being multiplied together. So you can do these the long way by multiplying rad 5 times rad 5, then rad 5 times 2, then negative 2 times rad 5, then negative 2 times positive 2. But you'll notice that the middle term will drop out. So what actually happens is that you have the square root of 5 times the square root of 5, which is 5. And we're going to subtract 2 times 2, which is 4. And that becomes 1, because these are conjugates. In number 31, these radicals have, this radical on the outside has to be distributed. It's a monomial times a binomial. So rad 3 times rad 2 is rad 6, and rad 3 times a positive rad 3 is 3. So we have rad 6 plus 3, and it's done. The last few are adding and subtracting. This is again review. Remembering that when we add and subtract with radicals, that the numbers inside the radicals have to match. They have to be like radicals or like terms, so to speak. We have 1 rad 2 plus 1 rad 2 here is one of them. Remember, this is understood to be a 1 in front. So the answer here is 2 of them, 2 rad 2s. For 37, we have 2 radical 3 minus rad 3. I'll let you figure that one out. I'm going to do 38. 2 rad 2 plus 3 rad 2. There's 2 of them plus 3 of them. That's 5 rad 2s. 39 and 40, similar procedure. And 41 and 42, if you simplify what's inside the radical first, you may find that you'll have some like terms to add together. These up here had no common factors, there were no like radicals because there was no way to simplify any of these. These are already simplified. But on 41 and 42, you can simplify what's given and then maybe add or subtract like radicals. For number 41, if I rewrite this 3 rad 6, that cannot be simplified, but rad 54 can. Let's see what's inside here. 9 times 6, there's a perfect square of 9, which is 3 times 3. So I can take out one of the pairs, 3, and I'm left with rad 6. Now I have 2 out 3 rad 6. So I'm going to take 2 and multiply it by 3 rad 6. So I have 3 rad 6 plus 6 rad 6, and that is 9 rad 6. And that's your homework for tonight, and I hope that you get it done and enjoy it.